Hey everyone, my name is Shreyas Sekar, and I'm an assistant professor of operations at the University of Toronto. I want to talk about some very exciting work that we've been doing on how you can learn product rankings, even when you have fake users trying to manipulate your system. So this is joint work with my excellent co-authors, Negin, Golrezaei, Vahideh, Manshadi, and Schneider. All right, let's begin with some intuition. I want you to put yourself in the shoes of a seller on Amazon who, no pun intended, is actually selling shoes. So if you're the seller, what's the number one thing that you care about once you have your product, right? And if you actually think about this for a minute, you'll realize that this is a very highly competitive market. So you're competing with 40,000 other sellers. You have 400 pages of search results. And as the old joke goes, if you really want to hide something, you should hide something in the 6th page of the Google search results. So putting all of this together, and especially the fact that most of your users don't even bother to go beyond the first page, the number one thing that the seller cares about is the position at which the product is placed, right? This is very, very important if you're a seller. So given how important this is, that's clearly an obvious optimization question that we should be asking. Now, if you're Amazon or any of the big e-commerce platforms, how do you come up with a ranking algorithm to rank the assortment of products that you have? The reason this is so important is what is basically known as position bias, which is a fancy term for something that's quite intuitive. All that means is that people pay more attention to the top ranked products than the ones at the bottom. So by deciding to place some products at the top and others at the bottom, you're basically coming up with a recommendation strategy because you're subtly recommending that your customers purchase the products at the top than the ones at the bottom. All right. So in view of this position bias, let's come back to our question. How do these platforms come up with ranking algorithms? And in general, the main idea that these platforms use is basically what's known as popularity-based ranking. So without going too deep into what popularity means, what these platforms do is a very simple online learning loop. Every time there's a customer, you show them a ranking. They collect all sorts of data from this customer, for example, clicks, products added to carts, purchases, etc. All of this goes into your black box, which in turn determines the ranking that is shown to the next customer. All right. So immediately going back to what we saw a couple of slides earlier, right? If you're a seller, you're really, really desperate that your product be ranked in the top position. So if you see this kind of a learning loop, the first thing that's going to come to your mind is how do I manipulate this loop in my favor? Now, in particular, if I can kind of control the data that goes into the algorithm, particularly early on during the learning phase, then maybe I can get my product in a favorable position. Okay. Now, turns out this kind of manipulation is not just a theoretical exercise in EC, but is actually something that's very, very common across all sorts of e-commerce platforms. And you may have seen these in different articles yourself. Basically, sellers employ everything in their arsenal to try to get their products to the top. Many of these legal, some of these completely illegal. In particular, what sellers do is they use this notion of fake clicks or fake reviews or fake purchases to really push their product to the top position. Okay, this is a huge problem for platforms like Amazon. And let's be completely fair. Amazon and other platforms do care about actually tackling these issues. Now, unfortunately, when it comes to the efforts that the platforms are taking on, they tend to be too little too late. Okay. Now, in particular, what I mean is that one, these fake users and bots are becoming increasingly sophisticated. So every time you try to catch maybe one approach that the fake users use, they come up with something that's smarter and you're kind of back to square one all over again. Okay. And two, by the time you're kind of detecting the actions of fake users, maybe you need a large enough pattern, the damage has already been done and your customers are suffering because maybe they're ending up purchasing suboptimal products. So given this challenge, I think the way to think about this is how can we be proactive in tackling fake users and not just reactive? Okay. Now, more formally and in the kind of sense that we are used to, here's the question that this work studies. Can we come up with an online learning algorithm that identifies or learns the optimal product ranking based on customer click data, despite the actions of fake users? Okay. So I'm not trying to detect what the fake users are doing. I'm just saying, hey, let these fake users throw whatever they have at us. I still want to know if I can identify the optimal product ranking. Now, what makes this problem challenging is that the number and identity of these fake users is not known in advance. Because if I had a bunch of data points and I knew which of these data points came from the fake users, then I can simply ignore those and just use the rest in my learning process. But because these fake users are sophisticated and because I can't separate their actions from that of the real customers, this problem is quite challenging. Now, let me clarify something and be upfront. This work is going to primarily deal with fake clicks as the main way that these fake users try to manipulate the system. Now, you can try to add other things such as fake purchases and fake reviews, and you can kind of extend some ideas on the model. But I think fake clicks are fairly representative of the larger problem. And more importantly, they may be even harder to detect compared to fake reviews. Okay, so let's focus primarily on clicks. And the model I'm going to use is this extremely well-studied cascade model, which a whole bunch of people have looked at in many different fields. So here's how this is going to work. You're a customer, you arrive to our platform, and I have a bunch of end products that I'm going to display to you in some particular order or some sequence. Okay. The customer starts with the product at rank 1 and works her way down to rank 2, rank 3, and rank 4, and so on. Now, for any given product, so let's say that product I is ranked at position 1. Then you can click on it with a product-specific click probability mu sub I. Now, if we click on it, we say that the customer is satisfied, and then they just leave the platform. Great, we're done. Now, if the customer does not click on the product, one of two things could happen. Okay, so with some probability Q1, which is dependent on the position 1, the customer can just exit the platform. We assume that they've reached the end of the road and they're not interested in looking at things anymore. Now, with probability 1 minus Q1, they can go back to product 2, and this whole cycle continues again, where they click on this product with probability mu sub j, then go on to exit or not exit, and then go to product 3, and so on and so forth. All right. So customers click on a product with some probability. If they click, we're great. If they don't click, then they may exit or they may go on to the next product. Now, the model that I've described so far is for real customers. What about the fake users? We don't really make any assumption regarding the fake users. In particular, out of a total of T customers, F of these are fake. The fake users can perform all sorts of actions. So one, they can click on a product to boost the platform's expectation of its click probability. Okay, but alternatively, what the fake users can do is they can avoid clicking on multiple products at the same time to let the platform kind of downplay their probability, right? So the way these platforms work is if I click on the product at position 5, then the assumption is that I've looked at the products in positions 1, 2, 3, and 4 and not clicked on this. So by clicking on the product at position 5, I'm simultaneously giving you a signal that I'm not interested in the first 4 products. So the actions of these fake users can be quite sophisticated. And again, let me reiterate what makes this problem challenging is that you cannot differentiate between the actions of a real and fake user. All right. So this is the basic cascade model with fake users. Now, given this model, our goal is to come up with an online learning algorithm to minimize regret. So here's how the cycle works. For each customer, you show them a ranking. You observe what products they click on and what position they exit. Okay, so these are the only 2 signals that you get from a customer. You can use all the click information and all the exit information to come up with a ranking for these subsequent customers. Our goal is regret minimization. So what we want to do is we want to maximize the number of customers who click on at least one product, aka these customers also go ahead to engage with the platform, compared to the optimal ranking, which just involves sorting these products in the decreasing order of their click probability. Okay, so we look at the number of customers who engage with the platform in the optimal ranking and subtract the number of customers who engage with the platform when it comes to our ranking. We study this platform in 2 settings. The first is the fake aware setting, where you know the aggregate number of fake users, that's F. 2 is the fake oblivious setting, where you don't know the aggregate number of fake users as well. And I'll talk about how this can kind of make a difference in your algorithm. Okay? All right. So let's start with something that's fairly obvious first. So when I say online learning, the first thing that many of you are going to think of, whether or not you have experience in the field, is UCB type algorithms, right? There's a huge bunch of papers on this area. And in particular, I think there are at least a dozen papers that extend UCB for learning to rank methods. So how do these UCB type algorithms perform when it comes to ranking with fake users? What we show is somewhat surprising. We show that with just log squared t fake users, remember, t is the length of your time horizon. So with f equals log squared t fake users, I can completely spoof my UCB algorithm to incur a linear regret. And the example that does it is actually very, very simple, right? So I just have two products. What I'm going to do is I'm going to have my fake users arrive at the beginning. Now, these fake users behave in very specific ways. They inflate the click probability of an inferior product, and they deflate the click probability of a better product. So remember how UCB works. You're going to use the first log squared t or log t users to kind of learn something about the click probabilities or rewards. So when I'm kind of completely messing up with the algorithm in the beginning, then UCB starts thinking that the worst product is the better one and the better product is the worst one. So you're going to kind of mix up your ranking, and this is going to lead to linear regret for all subsequent customers, right? And this is really why these sellers try to engage with fake users. It's not because just that I want to kind of spoof my customer, but I want to trick my algorithm into coming up with suboptimal rankings for all future customers, okay? So one bad action right now can really lead to adverse consequences later on. All right, so UCB does not work. What kind of approach can I use? So let's consider the first setting where I know the aggregate number of fake users, okay? So we're going to introduce two simple ideas. One is this notion of having a confidence interval and having it proportional to the number of fake users, F. What do I mean by that? At any point in your algorithm, I'm going to track the empirical click probability of each product I. Now, let's say that Ri is the empirical click probability of product I. So I'm going to keep an upper bound and I'm going to keep a lower bound. But I think compared to maybe more traditional approaches, I'm going to extend this interval so that it tracks the number of fake users along with your standard inequality kind of Hofting kind of bounds. Okay, that way I'm making my confidence interval somewhat robust to the actions of these fake users. Now that's number one. Number two is, in addition to kind of maintaining these intervals, I'm going to maintain what is known as a pairwise product relationship graph. So again, at every point in time, I'm going to maintain a graph whose nodes are the different products. Okay, I'm going to have an edge, but from product I leading up to product J when I know that product J is better than product I. Okay, now as I start populating this graph, I'm getting partial information about which products are better and which products are worse. Now the way I select the ranking, once I populate the graph, now remember, if you have no errors, this product would be a directed acyclic graph. So the way to select a ranking is to use a topological ordering of your pairwise graph. Okay, we call this the fake-aware ranking algorithm, and we show that this gives you regret that is additive in the number of fake users F. Now this is actually unavoidable. So just to give you intuition on why that's the case, remember that if you have, if all of your users are fake, then you're going to end up incurring completely linear regret because you can't learn anything useful. All right. Now, what happens when I don't know the number of fake users F? Okay. In this case, I can't keep track of the confidence interval and keep them proportional to F. So what do I do in this case? What we're going to do is we're going to create multiple parallel algorithms that track different fake user counts. Okay. And let me be a bit more specific about what I mean. So we use this idea of multi-level learning that was proposed in a recent work by Golrezaei et al. And the way this works is that you keep track of parallel copies of your algorithms. So each level is one parallel copy, and each parallel copy has its own product ordering graph. Okay, these different parallel copies are not equal. So the ones that are at the lower levels, we're going to select them with a higher probability. So this means that they converge very quickly, but they may make mistakes. The so-called higher levels are selected with a small probability, so they converge slowly, but they don't make mistakes. Now, you have these different things happening at different levels, and each level has its own strength. The main idea is to connect these different levels by this notion called bidirectional cross-learning. Okay? Now, because these lower levels can make mistakes, what we do is every time we learn an edge at a higher level, we transfer this edge to the lower level because the higher levels don't make mistakes. Similarly, because the higher levels are slower and they get very few samples, we partially transfer samples from the low level to the high levels so that you kind of speed up the learning process in the high level. What we show is that this algorithm, which we call the fake oblivious ranking with cross-learning, just a long name to say fork, incurs a regret that's multiplicative in the number of fake users f, as well as a standard bandit regret of its log t divided by delta. All right. So let me sum up the main ideas here. One, the main thing you want to go home with is that your traditional learning to rank algorithms can be manipulated by users. Two, is that we come up with a ranking method that's prescriptive and that converges to the optimal ranking, whether or not you know the number of identity of the fake users. Three, and something that I did not present, is that we get much better bounds when these fake users are spread out and we make additional assumptions on their structure. Right. So the main high-level intuition here is this notion of multi-level learning, being more conservative in how you learn, and kind of using randomization to thwart the fake users. So many of these insights are applicable to other notions like fake reviews, fake likes, etc. But this is something that we're actively exploring as well. So if you have any ideas, I'd love to talk about them offline. So with that, thank you so much. Happy to take questions.